This is question 2 from the two-dimensional motion mock test. Simone fires a flaming digital projectile at a speed of 13 meters per second at an angle of 71 degrees above the horizontal on a long level firing range. So here's our long level firing range. Not so long, is it? Right? And then she fires it at 71 degrees. And it's 13 meters per second. 2 digits are giving me like this, right? And the question is, and of course this projectile is going to go nice symmetrical trajectory because we're going to ignore air friction for this, right? Okay, and we want to know the initial horizontal and vertical components of velocity, what time the projectile is in the air, what distance it goes before hitting the ground, and what is the greatest height.
Hello, amigo.
Hey, I'm recording a video. This is Jose here.
Okay.
My friend Jose. Do you want to come here? Here. You're going to be on YouTube.
Huh?
This is my friend Jose.
Oh, okay.
It's like a review for the kids that didn't maybe weren't here or something for the test.
Cool. So you record now.
Yeah, here you go talking to this. What? Just say, are you recording?
Are you recording?
Yeah, we're recording.
Yeah, all right. So you do that, but no, the kids they're going now.
Yeah, well, this is just for kids that might be absent
okay.
or something like that. You know?
Some-
And this camera will upload it to YouTube. Isn't that cool? Yeah.
All right.
We go back a long way. Like I set off the fire alarm one time after school, and he had to. Remember that?
Oh yeah, I
Yeah, yeah.
remember. Yeah, that's true. So what they gonna do? What they gonna do there tonight? No.
No, they're to have the test Friday, but I wasn't here. I was gone today, so you know,
Okay.
this is just in case they didn't do their mock test.
Okay. Good.
Okay, so the first thing to do is to take this and break it into components. So you're going to want to find, so yeah, you're going to want to find this component here, right? And this one's going to be 13 sine 71 degrees, because that's our little angle there, is 71 degrees. Right? And this side here is going to be 13 cos 71 degrees, and that's because this is the adjacent side and that's the opposite side. It comes from SOHCAHTOA. Okay, so let's do those guys here. So let's go 13 cos 71, and I've got 4.2323. No, actually, the next digit would be 4, right? 2324, because it's 38 meters per second, and this side here, sine 71 is 12.292. Okay, 12.292 meters per second. Okay, and then it's very important that you check and make sure that you are in degrees. Okay, so I'm just double checking here because that would be very sad if I were. Okay, and now the next thing to do is to do the same thing and set up a horizontal vertical. Right, X, VI, VF, A, and T. Right, and these numbers go in there. This guy is my horizontal velocity, so 4.2324. And since the velocity or the acceleration in this direction is 0, the final is also 4.2324. Right. This guy here is going to go in here as my initial velocity vertically, 12.292 meters per second, right? And then the acceleration is negative 9.8 meters per second squared. Now the trick with this guy is that if it goes up and it comes down, when it hits the ground, it's going down with the same speed vertically. So that we've always solved problems that way. Negative 12.292 meters per second. That's hitting the ground. That's level ground. And the only time that's not true is if it's like a cliff. Like this is well, then it would hit faster, right? But this is not that case. This is nice level ground, right? Okay. And then, of course, this is 0. The net change in elevation vertically is 0. I'm going to find time by going VF is VI plus AT. So negative 12.292 equals 12.292 plus negative 9.8 times T to 9.8. So basically, I just take this number, multiply by 2, divide by 9.8. That's what it ends up being, right? And so the time is 2.5085 seconds. And then, of course, you can just sort of take that time and just kind of go across like that, right? So 2.5085 seconds. And then again, the only thing we ever do here is use this formula: V is x over t, or x is vt. So this times this will be this. So that times 4.2324 equal to 10.617 meters. Now we've filled the whole thing in. Let's see if we've answered our questions. Okay. What are the initial horizontal and vertical components of velocity? Well, this is horizontal. They're right here. So 4.23 in the x direction, 12.29 in the y direction. Right? What time is the projectile in the air? Well, here it is. 2.5. You'd say 2.51 if you were rounding seconds. Yeah. And then what distance does it go before hitting the ground? The answer says 10.6. That's just this rounded. Right? And then C says, what's the greatest height the projectile reaches? What's its velocity at that height? Well, let's answer the question, what's its velocity at that height? At this height, at the top, the final vertical velocity at the top is what? It's 0, because if it's not 0, it's not at the top, is it? Right? So at the top, the velocity it's got is 4.2324. That's the, right? That's how fast it's always going horizontally. And when it's at the top, it has only horizontal velocity. So therefore, that's how fast it's going. But the greatest height, we're going from here to the top, right? We just have to set up a x, vi, vf, a, and t, right? Going to the top, the initial vertical velocity is 12.292. The final vertical is 0. The acceleration is negative 9.8. And we want to find x, right? So this is at the top, right? Okay. I would use vf squared equals vi squared plus 2ax. Right? And so I can plug those numbers in. I'll plug them in down here. 0 squared equals 12.292 squared plus 2 times negative 9.8 times x. So it's going to be this squared divided by that, right? 12.292 squared divided by 2 divided by 9.8. 7.70884. So this distance here is 7.70884 meters. And the sheet says 7.71 meters. Yeah, there we go.